All right, so we're looking at 7.5.1, so it's the 7th grade textbook, Chapter 5, Lesson 1, Algebraic Expressions. It begins on page 349. So on your paper, you need to head the paper 7.5.1, Algebraic Expressions, page 349. We're going to skip down to the real world link where it says the expression f minus 32 times 5/9 can be used to convert the temperature from Fahrenheit to Celsius. In this algebraic expression, the variable blank represents the temperature in degrees Fahrenheit. Hopefully this is kind of an easy one for you guys. The f represents the variable f, and it's a capital F. I know that looks a little crazy. Okay, well there you go. F represents the temperature in degrees Fahrenheit. No, you don't have to write that down unless you just like to. I think that's pretty much common sense. This whole section might be pretty easy. So it says evaluate an algebraic expression. The branch of mathematics that involves expressions with variables is called algebra. In algebra, the multiplication sign is often omitted. So when we have 6d, it's 6 times d. When we have 9st, it really means 9 times s times t. So when there's no sign there, it does mean multiplication. Now, a to the third power would be a times a times a. The numerical factor of a multiplication expression that contains a variable is called a coefficient. So 6 is the coefficient of 6d. So the numerical factor of a multiplication expression that contains a variable is called the coefficient. So the letter, it's the number that goes with the letter. So it's 6 times d, 6 is the coefficient. An expression like y divided by 2, that can also be written as 1/2 times y. And so 1/2 y is the same as y divided by 2. And in this case, then the coefficient would be 1/2, which I think you definitely want to write this down, okay, about coefficients. And if these examples are helpful, you can write these down as well. Pause the video if you need to go back and write. All right, so examples number 1 and 2, just to review the order of operations, it's please excuse my dear Aunt Sally, but I like how they've showed it here because it's very important that you remember that multiplication and addition and subtraction are like partners. They go together, and it doesn't matter if it's division and multiplication or multiplication and division, you go from left to right. Okay, so number 1 says evaluate the expressions inside grouping symbols. Number 2, evaluate all powers. Number 3, multiply and divide in order from left to right. And then number 4, add and subtract in order from left to right. So this is our please, and then our excuse, my dear Aunt Sally. All right, so write this down if you haven't already. Pause the video if you need to. So example number 1 says evaluate 2 times, and in parentheses, n plus 3 if n equals -4. So this is where the new stuff comes in, because honestly this is not new. The idea of using order of operations is not new, but using it with negatives is now something that we haven't done before. So I would rewrite the equation and make it 2 times, in parentheses, -4 plus 3. I would do my -4 plus 3 because what comes inside the parentheses goes first, and that would make -1, and that's going to be 2 times a -1. When you multiply, you have different signs. It's negative. Multiply like normal, it's going to be -2. Number 2 says evaluate 8w minus 2v if w is 5 and v is 3. And this is one of those ones that I would like you to definitely write down. Because sometimes you guys want to do, oh, it's 85 minus 23. And that would kill me if I ever saw that written down somewhere from one of you guys. It is 8 times 5 and 2 times 3. So this is going to be 40 minus 6, and then we do 40 minus 6 is 34. But it's really important for you to remember that it's not 85 minus 23, because that's not going to be 34. It's 8 times w minus 2 times v is what we're looking at. Example number 3 uses exponents here. So we've got evaluate 4y to the third power plus 2 if y equals 3. So we're going to do 4 times 3 to the third power plus 2. And remember that 3 to the third power equals 3 times 3 times 3. So that's going to be 9 times 3, which is 27. And so it's going to be 4 times 27 plus 2. 4 times 27 will go first because multiplication comes first. And then adding 2, we get 110. This might be another one of those things that you want to write down if you don't remember that 3 to the third power is 3 times 3 times 3. All right, you're going to do A, B, and C on your own. When we come back, we'll go over the answers. All right, so here are the answers for A, B, and C. A is 5, B is 7, and C is 9. I mean, they're all pretty much self-explanatory. I think that letter C was the hardest one, but we're talking about 3 times, and we would substitute the C is 8, and the D is -5, so it's 8 plus a -5, and then another parenthesis there. I guess that's really sloppy looking. And so then I would need to do this math first, which is 8 plus a -5, different sign, subtract, take the sign of the higher absolute value. So it's going to be a +3. So 3 times 3 ends up being 9. So now you're going to do D, E, and F on your own, and then come back to the video and I'll show you the answers for those. Pause the video now. All right, and the answer to D is 36. These got trickier as we went along here. So it's going to be 2 times 8 minus 4 times -5. I did 2 times 8, which was 16, and then I did 4 times -5, which was -20, and then I put back in the subtraction sign. Now you could have thought of this as -4 times -5 and made it a +20, which look, it would have come out to the same thing anyway. Because we know that if we are subtracting a negative, then we're adding its opposite, and so it ends up being 16 plus 20, which is 36. For E, we had -5 minus 8 squared. Now, the part that was squared was just C, so it's not -8 squared, it's 8 squared. It's subtracting 8 squared. So that's why I have -64. And so I'm doing -5 plus a -64 is -69. For F, we have 2 times -5 squared. This time it is all of -5 being squared because that's what number D is, and D is being squared. So it's -5 squared. And so plus 5 times -5, so it ends up being 2 times +25, because -5 times -5 is +25, plus 5 times -25. So we end up being 50 plus -25, which is 25. Different sign, subtract. So that one was a little tricky. For example number 4, it says the athletic trainers use the formula 3 times 220 minus A, all of that divided by 5, where A is a person's age, to find their minimum training heart rate. So find Latrina's minimum training heart rate if she is 15 years old. So we take the 220 minus 15 times 3, so that's where we go straight to here. And so that's going to be 205 times 3 divided by 15. You have to multiply, and it's 615 divided by 5, which is 123 beats per minute. If you want to write that out so you see all of the steps, that's fine. If not, just an extra example. Right here it says the fraction bar is a grouping symbol, so evaluate the expressions in the numerator and denominator separately before dividing. This is a really key piece of information. It's saying take care of everything up here until there are no operations left, and then you can deal with the dividing by 5. That's a really good point. Alright, now pause the video again and work on G. It says to find the area of a triangle, use the formula base times height divided by 2, where B is the base, H is the height. What is the area in square inches of a triangle with a height of 6 inches and a base of 8 inches? You guys should know how to do this pretty easily because you've done this in Chapter 9. Alright, pause the video now. Alright, so when I substituted in my 6 and my 8 for my base and my height, I came out with 24 inches squared. Base times height divided by 2 is going to be 48 divided by 2, which is 24. Alright, so write expressions. To translate a verbal phrase into an algebraic expression, the first step is to define the variable. When you define a variable, you choose a variable to represent an unknown quantity. You don't have to write this down yet. You guys have already learned this. Example number 5 says Marissa wants to buy a DVD player that costs $150. She already saved $25 and plans to save an additional $10 each week. Write an expression that determines the total amount of money that Marissa has saved after any number of weeks. So in words, we want to know what it is where it's $25 plus $10 each week. So the variable is going to be weekly, the week, which is W or whatever they want to use. We're going to have to multiply that amount times 10 and then add in that $25 that she already put away. So 25 plus 10 times W is the final expression that we're talking about. So if you'd like to write down the example, you may, but you don't have to. If you already started, haha, go ahead, finish up. But this is probably a good way to go. All right, number 6 says, refer to example number 5. Will Marissa have saved enough money to buy a $150 DVD player in 11 weeks? They're just giving you something to substitute in. They're telling you how long the W is now. And so we're going to substitute in the 11. And we're going to do 10 times 11 is 110. And then add in the 25. She would have saved $135 after 11 weeks. But is that enough? It is not. Because that's not $150. She cannot afford to buy the DVD player yet. An MP3 player costs $70 and song downloads cost 85 cents each. Write an expression that represents the cost of the MP3 player and X number of downloaded songs, and then find the total cost of 20 songs that are downloaded. So go ahead and copy this scenario down and then answer it. Pause the video now. Alright, so to start, we're definitely paying $70 for the MP3 player, so that's $70 plus 85 cents for each download for X number of downloaded songs. So we're going to do 85 cents times X is the other half of our equation here. So we've got $70, and they said we're going to get 20 downloads, so we're going to do $70 plus 85 cents times 20. 85 cents times 20 downloads is $17. And so it's going to be $70 plus 17, which is $87. All right, and that ends our lesson. If you have any questions, make sure you let me know in class. I'll see you in school. Bye.